is here today with us. Okay, so welcome. Okay, so we would like to request everyone's participation. If you can actually see and hear us, and of course, if you can actually view the slides on the screen, kindly send us a just comment on the chat box, a thumbs up, just to confirm that you can actually see, hear, and view the slides on your screens. Okay, thank you so much. So I can still see participants coming in, which is good. It's amazing. All right. Thank you so much. Okay. Thank you, Shalindra. Thank you, Gian. Thank you, Alex. Okay, that's amazing. Innocent, thank you. Carlo, Crystal, thank you so much. Okay, good. Okay, thank you so much. I can see thumbs up here, Azzy. So, which is good. So they can actually see. And from your end, Azzy, can you see the control option perhaps on your screen so that you can actually take control of the slides after my part?
Yes, yes, I could navigate hours.
Can we do a test perhaps?
Yeah.
Amazing. Thank you, Tibin. Thank you, Jamie, Sarosh, Desiree. Thank you. So for those who just came in, again, we would like to request from you guys if you can actually see here and view the screens, our screen. So yep, just send us a thumbs up to confirm that you can actually um, yeah, as mentioned, see our screens as well. All right. Thank you so much, everyone. Oh well, from Zambia. Welcome, Zambia. Amin. Thank you. Welcome, Amin. So much. Still see here. Okay. Thank you so much, everyone, for sending us a thumbs up, which means we'll be able to continue this webinar with clarity and, of course, laser focused attention. Okay. So before anything else, we'd like to remind everyone, a little bit of housekeeping in terms of notifications. So we want you guys to have a laser focused attention on this webinar. So we would like to request from you guys on the upper top of your screen, you can actually see a settings option on how to turn off or disable those notifications and sounds so that, again, you will have a laser focused attention on this webinar, okay? So, yep, instructions are on your screens. And then at the same time, there will be a short Q&A after this together with Engineer Asi here. So if you do have any questions, please post it in the Q&A section on the upper part of your screens. Okay. Thank you so much. And then, yeah, for those common questions and FAQs, so basically for those who have registered, you'll be able to receive the slides and copy of this recording um, for the next 2 business days. Okay, so just kindly check your junk mails as well because these emails usually go straight there. So if you're using Gmail, you can also check the promotion and social section of your inbox. Okay, so since this is a technical topic webinar, those who will stay tuned until the end of this presentation, you'll be able to receive a certificate of attendance for this technical webinar. So basically, I will be putting some instructions on how to get your certificate. So there will be a survey that you need to fill out, and then you'll be able to receive your certificate. We will endeavor to send that one in the next 4 business days. Okay. Thank you so much. And yeah, a little bit of EIT. So for those who are new here, we are actually dedicated to ensure that students receive the world-class education and then gain skills that you can immediately implement in the workforce. So we are an education provider based in Perth, Australia. We also have a campus in Melbourne. And then recently, we just opened our campus in Brisbane. So we specialize in engineering courses. We offer a wide range of programs, starting from our professional certificate course. We also have our advanced diploma courses, and our bachelor's degree, graduate certificate, graduate diplomas, masters, and of course, our doctor of engineering, which is the highest level. So these programs are actually designed. I mean, these are industry-oriented programs, which means these are very, we provide you skills and knowledge which are valuable to our to employers. Okay, and then some of our programs, okay, vocational and of course our higher education programs are accredited by the Australian government. Okay, at the same time, accredited by engineering bodies, namely Sydney, Dublin, and of course Washington Accord. Okay, so, yep, these programs also are delivered by industry experts, okay, like Engineer Asi here. Okay, so, yep, and then we are delivering this in a unique delivery model, such as webinars like this. And also, we are proud about our virtual and remote laboratories, okay, so which makes use of simulations and softwares. And of course, someone also asked, do you have a dedicated learning support officer? Yes, that's something that our school is proud of because we have dedicated learning support officers. Okay, so yep, today's topic webinar would be integrated risk management and assessment frameworks, which will be delivered to us by Engineer Asi Soltani. Is actually she's actually a civil engineer and EIT lecturer, and then I will give her the freedom to introduce herself further. Okay, so
Thank-
Doc, Engineer Ali, please, the floor is yours. Thank you.
Okay. Thank you, Marvin. Thank you for all your support during this session. And hello, everyone, and thank you for joining today's webinar. I appreciate for having you here. I'm Asya Sultani, a railway specialist IT and lecturer with a passion for rail infrastructure, safety and system optimization. And my focus on making railway more efficient, reliable, and sustainable. I have a background in railway engineering, civil engineering, and business administration, and I specialize in track design, ramps, and system engineering. I also teach industry focused railway and safety courses at the Engineering Institute of Technology, and I joined EIT by November 2020. I believe the smart engineering and system thinking, things like requirement traceability, safety system estimate, safety system management, and the V model for frameworks can help us to improve safety and efficiency in railway project. And please post any question under Q&A functions at the top right-hand corner. Everyone registered for this webinar will receive a copy of the PDF as Marvin mentioned here, and you will receive the certification after this session.
Um,
And for agent,
Sorry to cut
sorry,
you off,
go.
Engineer Asik. Would you be able to take control of the screen? I mean, the slides. It's on the upper top of your screen. Take control so that you can control the slides. And yeah, perfect. Thank you so much.
Thank you. Introduction. But why is risk management critical in infrastructure? The topic of this webinar is about introduction to integrated risk management and risk assessment framework. The agenda are understanding the need for integrated um, risk management, defining risk management and risk assessment, ISO 31000, and also CSAR 114 in Canada, the importance of integrating risk across technical, financial, and operational and regulatory domains. And we will review why traditional risk management is no longer sufficient. And we will review key risk management framework in infrastructure and energy sectors And we will review some standards for ISO 31000, CSAR 114, and Victorian Government Risk Management Frameworks, NIST Security Framework, Cybersecurity Framework, and service and some digital risk integration for real-time decision-making standards. And we will review in this webinar the role of risk assessment in IRM and the process of implementing IRM in infrastructure and energy projects. After that, we will review some industry-specific case studies regarding rail and transportation, energy and oil and gas, renewable energy, and at the next, we will review how IRM enhances the decision-making and compliance. And finally, we have some sessions regarding conclusions and key takeaways. And we will go through interactive Q&A session and open discussion on implementing IRM in your industry. But as an introduction, why is risk management critical in infrastructure? The question is it's so infrastructure projects and operations involves numerous uncertainties and technical challenges and environmental hazards, human factors, and financial constraints. If risks are not properly identified and also controlled, they can lead to accidents, near misses, and also understanding accidents and near misses here is very important. An accident, we want to see what is the definition of accident, near miss, and incident. Maybe in your industry, this kind of the definitions should be different, but we will refer to the definitions as per the OSHA. As per the OSHA, the definition of an accident is an accident is an undesired event or a sequence of events that result in injury, ill health, or property damage. The Occupational Health, Safety and Health Administration, OSHA, defines an accident as unplanned, unexpected, and not purposefully caused event that happens suddenly and leads to injury or loss, decreased resources, values, and increased liabilities. However, before accidents happen, we often observe near misses. There are situations where there are situations where if conditions had been slightly different by just a few seconds or ignored by the chance we have some difference in times or distance, we will have a near miss instead of incident or accident. And an incident is an event that could lead to a loss of disruption to an organization, operation, services, or function. Introduction. We want to see what is the main key aspects and definitions regarding risk management and risk assessment. Risk management is the structured approach to identifying, assessing, and mitigating potential risks that could impact an organization's objectives. According to ISO 31000, risk management is defined as the coordinated activities to direct and control an organization integrating risk. ISO 31000 is built on three key components principles that these principles ensure that risk management is integrated, structured, and dynamic and adapting to changes and uncertainties. And the next one is the framework. These provide the foundation for embedding risk management into organizational culture and decision making. And the process this process defines the structure steps for identifying, analyzing, evaluating, and treating risk effectively. To be effective, risk management must be inclusive, consider human and cultural factors, rely on the best available information, and focus on continuous improvement by following these principles. And organizations can enhance resilience, improve decision making, and also achieve some sustainable success. In the next section, we will explore how these principles are applied in real world risk management. The next definitions of risk management process. Risk management, we reviewed that is a structured process. But for the processes of risk management, we have some communication and consultation, establishing the context, risk identification, risk analysis, risk evaluation, risk treatment, and monitoring and review the risk, and finally, recording and reporting the risk. And the next slide is about maybe you see this kind of PDCA cycle. This PDCA cycle is regarding plan, do, check, act cycle. This PDCA Deming cycle is for specifically safety management systems SMS framework. A safety management system, SMS, is a structured approach to managing safety in an organization. It ensures continuous improvement through the PDCA cycle, supported by strong leadership. At the first stage of our PDCA Deming cycle, we could see the plan phase. In plan, we develop the foundation for safety by identifying risk and setting policies. At the next step, we have planning phase. We define safety strategies and risk management approach. The next cycle is regarding do. In this phase of our safety management system, we implement safety measures based on the plan. And here we have risk profiling, identify, assess, and mitigate risk, organizing regarding allocate the roles and responsibilities for safety and implementing your plan. Put safety strategies into action. And in check phase, we have monitor and measure safety performance, measuring performance of the system, assess key safety indicators. Also, we have some investigating accidents, incidents, and near misses. In this phase, we analyze failures and we have lesson learned from incidents, accidents. And finally, the act. In this phase, we improve the system by taking corrective actions, reviewing the performance of them, and we evaluate and refine safety measures, learning lessons, apply insights to prevent future issues, and leadership's role. In this step, we provide some vision, directions, and commitment to safety and ensure that continuous improvement and accountability. Definitions of terms. For the risk management, we review that it's a systemic frameworks that applies policies, procedures, and best practices to identify, analyze, assess threats, and monitor risk to ensure they do not derail project objectives. As outlined in Victorian Government Risk Management Framework, VGRMF, this approach is essential for in infrastructure projects to minimizing the risk and enhancing decision-making process. And in infrastructure projects, these frameworks play a critical role, particularly in government-led planning. And risk management helps to mitigate threats related to the safety, costs, environmental impacts, and regulatory compliance, ensuring the project remains viable and sustainable. Their framework aligns with the ISO 31000 principles, but is tailored for public sorry, for tailored for public sector governance. It ensures that risks are not only identified and assessed, but also addressed through structured policies. Additionally, annual risk and compliance reporting are required to maintain transparency and accountability. By integrating this framework into infrastructure planning, we create more resilient, efficient, and future proof projects, safeguarding both public and private investment. And also in this slide, we will review some concepts of Rail Safety National Law RSNL and ONRSR guidelines. Railway safety is critical concern and risk management plays a key role in ensuring safe operation. Under the Rail Safety National Law RNSL, risk management is defined as the process of identifying, analyzing, and evaluating risks to reduce them as far as is reasonably practicable. And for rail operations face multiple risk categories, including track and rolling stock failure, which can lead to derailment or service disruption. Human factors such as fatigue and error, which contribute significantly to railway incidents, and some cybersecurity threats as digital systems become increasingly integrated into rail networks and environmental conditions, including extreme weather events affecting infrastructure resilience. To address these risks, the RSNL mandates safety management systems that incorporate structured risk management processes. Furthermore, all risk mitigation measures must follow the LR principles as low as reasonable practice and ensuring that risks are minimized effectively while maintaining operational feasibility. These guidelines, enforced by the Office of the National Rail Safety Regulator ONRSR, provides a regulatory framework that promotes continuous safety, improvement, compliance, and accountability within the rail industry. Also, here it's a checklist of APEGA. APEGA is some engineering institute regarding Alberta in Canada. The APEGA Risk Management Checklist, Appendix B, provide also a structured framework for identifying and mitigating risk across different stages of engineering and construction. One of the key areas of focus is ensuring a safe working environment for all of employees. A workplace that is safe, healthy, and hazard-free not only protects workers but also reduces liability for organizations. In Alberta, Canada, compliance with occupational health and safety (OHS) regulation is mandatory to uphold workplace safety standards, and a checklist based approach to risk management ensures that critical safety elements are systematically addressed, and this include providing a safe working environment for employees, ensuring all hazards are assessed and controlled, implementing exposure control measure to reduce risk, establishing emergency egress and evacuation procedures, and conducting regular safety training For example, a civil engineering firm designing railway station may implement regular site inspections to identify and mitigate construction-related risks. By integrating a structured checklist approach, organizations can ensure that safety risks are proactively managed and regulatory compliance is maintained and overall workplace efficiency is improved. At the next slide, we want to see, but what is risk management as per the ISO 31000 and what are the components? As per the ISO 31000, the components of a risk assessment are risk identification. This step involves determining what might happen that could negatively impact an organization's project or system. It includes identifying potential hazard, failures, or threats before they occur. And also risk analysis. Once risks are identified, the next step is analyzing the nature and level of risk. This includes assessing the likelihood and potential consequences of each risk, that helping organizations understand the severity of different threats. And the next component is the risk evaluation. Finally, organizations must compare risk levels against predefined criteria to decide on appropriate actions. This helps in prioritizing risk, determining acceptable levels of exposure, and also selecting effective risk treatment strategies. At the next slide, we will review some concepts regarding risk matrix in Victorian government risk management framework. That risk assessment here helps organization proactively identifying, analyze, and evaluate risk to minimize disruption and ensure compliance. A key tool in this process is the risk matrix, which categorizes risks based on their impact and likelihood. Impact categories risk are assessed across financial, operational safety and compliance dimensions, helping organizations understand potential consequences. Likelihood categories the probability of an event occurring is classified as rare, unlikely, possible, likely, or almost certain, and the action requirements or risks are evaluated against tolerance levels set by government and industry standards, guiding risk response strategies. By applying the risk matrix, organizations can prioritize risk effectively, ensuring that the high impact, high likelihood risks receive immediate attention while lower level risks are managed within acceptable thresholds. This structured approach enhances resilience, regulatory compliance, and strategic decision making. For Rail Safety National Law or NSL, regarding these standards, we have the risk assessment, risk assessment metrics for impacting the categories. We have financial, operational, safety, and compliance. We reviewed that likelihood. We had some likelihood categories and actual requirements. As an example for this one, we could say that by applying risk assessment frameworks such as AS 1742, the railway authorities can improve level crossing safety, reduce accident risk, and enhance public confidence in rail operation. But what is integration risk management and assessment? The integrated risk management, IRM. The integrated risk management is a strategic approach that embeds risk management across all levels and functions of an organization. And according to ISO 31000, IRM ensures that risks are not managed in isolation, but as part of a coordinated and structured process to enhance overall resilience and decision making in our organization. The key features of integrated risk management are interdisciplinary approach because the risks are managed across all departments, ensuring alignment between engineering, operations, finance, cybersecurity, and environmental teams. Governance integration. Organizational implement a unified risk methodology that promotes consistency and improves decision making um, and action requirement, unified risk methodology. As an example, here we could say a railway infrastructure project using IRM, integrated risk management, ensure that risk from engineering, operation, and cybersecurity, all of them are managed collectively rather than separately. For instance, addressing cybersecurity threats in rail signaling system must be coordinated with engineering and operational safety protocols to avoid isolated treatment. By applying some kind of this integrated risk management, the organizations improve efficiency, enhance regulatory compliance, and build a risk-aware culture that strengthens long-term resilience and sustainability. In the next slide, here we will review the CSAR 140 risk assessment for railway system in Canada. CSAR 140 establishes a systemic method for risk evaluation and assessment in Canadian railway system. This standard is designed to align with global best practices, ensuring that safety, efficiency, and regulatory compliance are fully integrated into railway risk management processes. The key aspects of CSAR 140 are broad applicability because a standard applies to any operational, technical, or organizational change, ensuring that all modification in railway system undergo proper risk evaluation and proactive safety measures. It mandates risk evaluation before implementing even safety changes and reducing the likelihood of unforeseen hazards and structure risk control because the CSAR 140 require a formalized approach to risk control, ensuring consistency across railway operation and regulatory alignment. The framework is based on European Commission safety regulations, promoting harmonization with international railway safety standards. By implementing this standard, Canadian railway operators can ensure proactive, structured, and globally aligned approach to risk management, ultimately enhancing railway safety, reliability, and operational efficiency. If till now all good, please show me thumbs up. And the next slide is regarding CSAR 140. It's regarding risk assessment for railway system. It's a critical standard that applies to any modification or change within a railway system. ensuring that risk assessment is embedded in all aspects of railway operation. This standard is designed to enhance safety, operational efficiency, and regulatory compliance. Types of change covered under these standards are operational changes, includes modifications in trains, schedules, the dispatching method, or passenger flow management that could impact railway safety, and technical changes covers new railway technologies, rolling stock updates, or infrastructure updates that require structural risk assessment, and also organizational changes. It encompasses some management restructuring, workforce changes, or shifts in safety policies that could influence operational risk. As an example, here we could mention the CBTC, automated train control system. This one control system that we use in some metro networks. Um, this standard mandates a structural risk assessment to evaluate potential hazards before full-scale deployment. This ensures that system reliability, cybersecurity threats, and operational impacts are carefully analyzed before implementation. By applying these standards, railway operators can proactively identify risk, implementing mitigation measures, and ensure safe and efficient railway system modification. Risk evaluation before implementing safety changes. There are some key components regarding risk evaluation here. We want to review them. First, hazard identification and risk qualification. Determining potential risks that could affect our system. It should be some operation system or any other industry, the operational part of that, and quantifying their impact and assessment of potential safety impacts by evaluating how this risk could impact passenger safety, infrastructure integrity, and operational efficiency. And finally, evaluation of risk mitigation effectiveness, ensuring that the process safety measure and control mechanisms effectively reduce risk to an acceptable level. In some cases, when we get the feedback from that safety management system, we figure out that it's not effective enough, and maybe we take another measurement and another measures regarding safety management system, another framework in some cases. As an example here, we could mention some high-speed rail implementation because before adding high-speed rail services, a rail company must conduct a comprehensive risk evaluation under CSAR 114 in Canada. This involves assessing by braking distance, track integrity, and passenger safety factors, including emergency response plan and onboard safety features. By applying this standard, the risk evaluation method, railway operators can ensure that new rail services meet the highest safety and reliability standards before full scale deployment. And in another part, here we want to review some key components of risk control method and risk control treatment. A structured framework for identifying and mitigating railway risk is essential to ensuring safety, operational efficiency, and regulatory compliance. This framework applies risk control method to proactively manage hazards and prevent disruption. The structure risk control methods include engineering controls, that it refers to implementing improved monitoring systems and also using redundant barriers in our system. The redundant barriers is referring to that barriers that we use as independent barrier in our system. When we want to improve the safety in our system, one way is that we increase the redundancy in our system to prevent any failures. As an example, in railway system, implementing improved track monitoring system and redundant braking mechanisms to prevent derailment and system failures, and also some administrative controls, emergency preparedness, and also as an example here for cybersecurity in some control system, in railway signaling system that has a control of the whole railway system, we could mention that a commuter rail system upgrading its signaling network must conduct a comprehensive risk assessment to evaluate cybersecurity threats. And under a structured risk control method, the operators must implement redundant fail safe mechanism to prevent hacking threats and ensure uninterrupted rail operations. By integrating engineering, administrative, and emergency preparedness controls, rail operators can enhance resilience, improve passenger safety, and ensure compliance with risk management standards. Infrastructure Australia's 2021 Risk Assessment Framework. Here we want to review the Integrated Risk Assessment IRA in Australia. It provides a structured approach to evaluating risk in infrastructure projects, specifically ensuring that they are assessed across multiple dimensions, including financial, social, environmental, and operational factors. According to Infrastructure Australia 2021, this approach enhances the IRM process in infrastructure process, and also it could help us during the decision making process, project feasibility, and long-term resilience in our system. The IRM process in infrastructure projects should include should be some kind of problems and opportunities and defining them. This stage focusing on identifying systemic risk early, ensuring that potential issues are recognized before project development begins, and identifying and analyzing options. Different infrastructure solutions are compared based on the risk profiles and allowing decision makers to evaluate safety, cost effectiveness, and also sustainability. Another key components include are we could talk about develop a business case. A unified risk methodology is used to justify project feasibility, ensuring that investment align with regulatory compliance, public safety, and long-term infrastructure needs. Example in railway in Australia, a railway infrastructure project using IRM integrated the risk management ensures that risk from engineering, operations, cybersecurity, and environmental factors are managed collectively rather than in isolation. As an example, when designing a new high-speed rail corridor, IRM helps assess track alignment risk, operational safety concerns, and also safety concerns in whole of our system rather than in isolation parts. By integrating IRM into railway infrastructure projects, organization can improve project success, rates and enhance risk mitigation strategies and align with global safety and sustainability. But why integrated risk management assessment? Integrated risk management is a holistic approach to risk management that ensures all risk factors are aligned within a unified strategy. The traditional risk management uh, has been some separate method with separate teams that handling technical, financial, operational, and compliance risk in different parts independently. However, this approach, integrated risk management, creates gaps solve that gaps that previously in some traditional models we have in our system. So for working around that gaps using traditional risk management system in risk oversight, we could use some integrated management system that leads to more effective mitigation strategies. Some key benefits are of IRMR, breaking down with it, the IRM aligns risk identification, assessment, and mitigation monitoring across all departments and enhance risk visibility because the modern digital IRM platforms improve risk oversight, automate compliance tracking, and streamline decision making process and proactive risk mitigation. A unified approach helps organizations identifying independencies between risk and implement more effective mitigation strategies. Examples for Metro Lake expansion project. A Metro Lake expansion project must integrate multiple risk categories. Some technical safety addressing track design risk to ensure operational reliability, financial risk addressing track design risk to ensure operational reliability, financial risk regarding managing budget overruns and funding challenges, environmental risk considering climate change and impact on infrastructure and resilience, operational hazard regarding preventing train scheduling conflicts and service disruption. By implementing IRM, organizations can ensure smooth project execution, regulatory compliance, and long-term sustainability. In all industry, it should be the construction project, it should be some oil and gas industry, a transportation industry. In the next slide, we will review why integrated risk management and assessment. Because this kind of frameworks, integrated risk management, um, it will give us the opportunity to address some of the challenges regarding risk management in isolation units, effectiveness. Integrated risk management addresses these challenges because, as an example, we could have the reactive, um, instead of reactive risk management system, we could use some proactive risk management methods. And the standard risk management is often reactive, but IRM addressing these kind of challenges regarding those reactive methods. This results in because the reactive methods result in delays and increased costs in mitigation. RM takes a proactive approach by integrating real-time monitoring, predictive analytics, and automated risk tracking, allowing organizations to anticipate and mitigate risk early before they escalate. And adapting to evolving risk because the traditional risk framework struggle to adapt dynamically to emerging threats such as cybersecurity attacks, supply chain disruption, climate change impacts, uh, and as an example, we could mention that in some metro projects with IRM implementation, for example, a metro expansion project, the climate risk assessment to prevent tunnel flooding. We could use also cybersecurity risk monitoring to secure automated train control system. In this slide, we will review some um, comparison between traditional risk and also some integrated risk management system. The standard risk management framework is regarding that we in that system we manage risk into separate categories with different teams managing technical, financial, operational, and compliance risk independently. This lack of coordination leads to gaps in risk oversight and ineffective mitigation strategies. Here, regarding the aspects of risk coordination, data collection, compliance focus, and decision making, and finally, incident response, we could see what is the difference between approach of traditional risk management and integrated risk management. As regarding the traditional risk management system, risks are managed independently, and but in integrated management system, risks are managing in coordination between different disciplines and ensuring we have some enough coordinated strategies. And also as well for data collection aspect and decision making process, we have similar approach. But how IRM addresses the gaps in traditional risk management? Because the IRM provides us with the collaboration across risk domains and ensure that financial, operational, technical, environmental, all risks are considered together, preventing gaps in oversight and also automated risk tracking that enable proactive risk mitigation by continuously monitoring potential hazard, data-driven insights, enhance risk decision making by leveraging real-time analytics and AI-based assessment, real-time risk reporting by helps predict and prevent failures before they occur, reducing operational disruption. For example, we could mention IRM in high-speed rail networks. High-speed rail networks implementing service now IRM integrates in some cases, and it could help us to track monitoring sensors, predicting maintenance needs before faults occur, ensuring uninterrupted operations, and automated compliance reporting by preventing regulatory violations by ensuring continuous safety checks, and cyber risk tracking by monitoring for potential hacking threats to protect automated train control system. By adapting IRM technologies and digital platforms, labor operators can optimize safety, reduce financial risk, and improve overall infrastructure resilience. At the next slide, we will review some aspects regarding why infrastructure projects need IRM. Because it will give the traditional risk management struggles to keep pace with today's dynamic infrastructure challenges. And IRM provides a holistic data driven approach to risk mitigation, ensuring proactive rather than reactive responses. Advanced risk platforms like ServiceNow IRM enable real-time risk tracking, automated compliance, reporting, and predictive analytics for infrastructure resilience. The benefits of IRM for infrastructure projects are ensure resilience, cost effective, and security in project planning, and aligns risk across engineering, finance, and operations, enabling better decision making, helps prevent failures before they occur, reducing long term costs and improving public safety. The core message here is integrated risk management is not just about avoiding risk, it's about building sustainable, efficient, and safe infrastructure for the future. Integrated risk management in the energy and oil and gas industry. Why IRM is critical in the energy and oil and gas industry? Because it will give us the better future uh, rather than traditional aspects in energy and oil and gas industry. Why IRM is critical in energy and oil and gas industry? Why RM is critical in energy and oil and gas industry? The problem is that an aging pipeline system, as an example in Alberta, was prone to undetected corrosion, as an example. It's increasing the risk of oil spills and environmental contamination. The company had separate risk management processes for safety, environmental impact, and financial and operational aspect of this kind of problems. So, in traditional risk management failed because we don't have any correlation between risk factors in some kind of these factors, or lack of automated risk alerts, or regulatory non-compliance fines. So, how IRM prevented a major oil spill in Canada as an example? The integrated risk management transformed this pipeline operations because the solution is using some AI driven pipeline monitoring. It could help us that we have some detected corrosion trends before failures could occur, and we have some integrated risk dashboards regarding safety, environmental, and financial teams receive real-time alerts, ensuring rapid response, and also automated compliance tracking ensure full alignment with regulatory bodies like the Canada Energy Regulator, CR, and API-RP 1173 safety guidelines. The results are some oil spill prevented using IRM, saving millions in cleanup costs and legal fees, and regulatory compliance improved by 40%, reducing penalties, and operational efficiency increased by 25% thanks to predictive maintenance. Here we could see how IRM improved decision making process, specifically in energy projects. Here we have some comparison between traditional risk management and IRM in oil and gas. We have regarding the aspect of risk visibility, data tracking, incident reporting, and compliance oversight. We have some improvement in IRM that we could say it could help us in decision-making process, specifically in energy projects. But what is the role of framework here? We talk about integrated risk management and assessment um, frameworks. A risk management framework provides a structure, repeatable, and a standardized approach to identifying, assessing, mitigating, and monitoring risk. But how do frameworks support integrated risk management? Ensure consistent risk identification, assessment, and mitigation across domains like safety, financial, and environmental risk, provide governance structures that defining roles, responsibility, and escalation procedures, align regulatory compliance with international and industry specific standards, allow organizations to integrate emerging risks like cybersecurity, supply chain disruption, and also climate change into decision making process. As an example, a railway operator in Canada using CSAR 140 and also in Australia, ONRSR, a railway operator in Australia, must adhere to a structured risk management framework to ensure that safety, technical, and operational risks are effectively managed. This framework helps operators standards risk assessments to enhance safety and ensure compliance with regulations. How the frameworks works in practice. In CSAR 140 mandates a structural risk assessment for any modification or change within a railway system by implementing new technologies like automated train control. And in Australia, ONRSR ensures that assessment for any modification or change within a railway system. Um, and also it ensures that railway organization maintain a safety management system which includes risk identification, assessment management, and also continuous monitoring. And these are some commonly used frameworks in IRM infrastructure, energy, and transportation, as you see here. Some frameworks regarding ISO 31000, CSAR 140, Victorian Government Risk Management Framework, and NISC Cybersecurity Framework. And these are some kind of main framework that we reviewed during this webinar. But what are the role of frameworks? How these frameworks support our IRM? By enable cross-industry risk integration for multidisciplinary projects, ensure compliance with national and international regulations, by facility and automated risk tracking, and by improved decision making with real-time risk monitoring. And as a conclusion, the key takeaways from integrated risk management and assessment framework. Why IRM matters? Because traditional risk management operates in isolated process, which can lead to some fragmented risk visibility, delayed response, and also insufficient resource allocation. IRM provides a holistic approach and data driven approach to risk identification, assessment, mitigation, and monitoring. And industry frameworks, regarding the frameworks that we reviewed in this webinar, they help us for operational efficiency and long term resilience in our system. And we review some key benefits of integrated risk management frameworks regarding cross-functional collaboration, real-time monitoring and predictive analytics, regulatory compliance and assurance and resilience and sustainability. And also, we could have some challenges in adapting IRM in our system regarding resistance to shifting from traditional risk management models, need for technology adoption, increasing cybersecurity risk in specifically in rail, energy, and infrastructure projects, and compliance challenges with evolving global safety and environmental regulation. The next step to strengthening IRM should be adopt digital risk platforms, align multi-industry risk assessment method, and train professionals in this field, and leverage AI and predictive modeling for real-time risk forecasting. And thank you for having you here. Do you have any question regarding this webinar?
All right, thank you so much, Engineer Asi. So before anything else, let me just control my. Okay, let's just control the slide. So basically, what are the courses? Okay, just a sec. Okay, so basically, what are the courses covered this topic? So basically, we have these multidisciplinary webinar, basically for civil engineer, mechanical, electrical engineering, and industrial automation. So if you do have any inquiries within one of our courses, please feel free to reach us here at EIT, and of course, our course advisors team would be happy to, of course, assist you with your inquiries. Okay, so yep. Um, so yeah, just again, we would like to announce that we will be having another EIT Virtual Open Week this coming April 21. So the goal is to actually provide future students and of course students an comprehensive overview of what EIT has to offer. So this includes a series of live webinars, recorded sessions that actually covers the aspect of engineering at EIT. Okay, so basically this event aims to help attendees understand why engineering is a great career choice and why EIT is suitable place to pursue engineering studies. Okay, so if you're interested, we will be posting the information on the website, and then yep. And yeah, hope to see you there. So if you are interested, we will be posting that one in our website. Okay, so for Q Q&A session, we do have some questions here, Engineer Asi. So I'll start with this one from Andrew Hewitt. So how does an organization manage prioritization between competing categories when using IRM? For example, competing priorities for financial risk versus managing. Okay, managing safety risk, which may cause additional financial burden in achieving SFA IRP, the risk management outcomes. Engineer Asi?
Yes. For prioritizing risk in different industry, to be honest, this IRM is not much sure that we have another specific method for that one. But currently, we could use some risk matrix method that regarding the risk is not defined. It's regarding which discipline we could prioritize them as per the level of the risk that they could impose to our system. It should be regarding the financial phase and it should be regarding environmental phase. And I could say in different industry, this prioritization should be different as per the industry priority also as well priority. And another question. Could you help me to find, sorry, Marvin, what was another question?
Um, so yeah, that's actually the question that I have. So yeah, okay. We have one here from Joshua. So does the IRM offer a revised risk assessment matrix that shows the likelihood and probability of hazards and risk? If so, can that be provided? That's actually from Joshua Tingdwe, if I pronounce it right.
Okay,
It's on the Q&A session section, engineer.
okay, okay.
Yep.
Okay, I find it. How does an organization manage? Yes,
The upper
the
the
yes,
upper
I
top one.
find it.
That's IRM. Yep.
The IRM offers a revised assessment matrix that was the yes, but it's this risk matrix that shows the likelihood and probability of hazard, and this is part of the risk management, not specifically for integrated one. It should be the same for traditional models and also integrated models. But for the revised assessment matrix, as I know, we don't have any specific revised version.
All right. Okay. So yeah, hopefully that answers your question, Joshua. So we have another one from Abdul Rauf. What skills do you think will be the most critical for engineers in risk management over the next decade?
It's hard to see, but maybe you could help us type in the chat box what should be the challenges. But one of the most challenges that we could have is that implementing the AI and new methodologies in our system. It has some challenges, threats, and also some opportunities for our system. So we have to, and also it has some aspects, and the numbers of unknown in our system is really high. So um, how we work around that kind of unknown and uncertainties in our system should be some challenging parts, and because we don't have also any historical background in our system regarding that ones, because it's a new topic. We don't have any history regarding the threats of threats related to AI and new technology in our history and background of our organization.
Hmm. Okay. Thank you so much for that, engineer. So, Abdul, I hope that answers your question as well. So, yeah, I think we don't have that much time, engineer. So, for those who are asking about the certificates, so here it is. Okay, so just kindly scan the code on your screens, and then I'll be posting in the chat the link where you can actually get your certificate of attendance. So basically it will lead you to a survey form wherein you need to complete on that one, and then it will just kindly wait for your certificate. So again, we'll be sending that one in the next 4 business days. Okay, so I have posted the link on the chat box. Okay, all right. Thank you so much, everyone, for being here. Thank you so much, Engineer Asi, for sharing those information with us. So, yep, again, we do have an EIT Open Virtual Week. Okay, so if you wanted to know more about EIT, please register on that one. That would be again this coming Monday of starting 11th of April 2025. Okay, as you can see on your screens. All right. Thank you so much, everyone. Any last words, Dr. Asi? I mean, sorry, Engineer Asi.
Thank you all for participating in this webinar, and thank you for interactive session, and thank you Marvin for supporting us during and hosting from AIT this webinar.
Thank you
And
so
have a
much, then.
good time all,
Thank you so much,
and
Engineer Asi. Thank you, everyone, for attending, and see you in the next
bye
in the
everyone.
future webinars. Bye for now.
Yeah,
See ya.
see you. Bye.